5.3 is going to be about double angle formulas. And double angle formulas are going to come from some of the formulas that we talked about in section 5.2, which come from the sum and difference formulas. So the three main double angle formulas that we are going to see is sine of 2 times theta, which is equals to 2 times sine of theta times cosine of theta. Then we have cosine of 2 theta. So whatever the angle is in the argument is being multiplied times 2. And we want to be able to rewrite it in a form that doesn't include the angle being multiplied by 2 or anything like that. So we're trying to find the answer of something more complicated by only using sine, cosine, and tangent. That's the whole idea. So cosine of 2 theta is the same thing as cosine square of theta minus sine square of theta. And then tangent 2 theta is equals to 2 times tangent of theta divided by 1 minus tangent square of theta. So let's talk about how those came about. So like I said, the double angle formulas come from the sum and difference formulas. So if you replace alpha and beta by theta in some of the functions. So for example, sine of 2 theta, we can rewrite it as sine of theta plus theta. And so if you look at that, we can use the sum formula for sine, which means that it'll be sine of the first times cosine of the second angle plus cosine of the first times sine of the second. So right here in purple, I kind of wrote the formula to reflect what's going on above in the black. And that's how we get the formula itself. Same thing with cosine of 2 theta. It is the same thing as cosine of theta plus theta. So if we replace those definitions with the sum formula for cosine, then we get the following, right? Cosine of theta times cosine of theta minus sine of theta times sine of theta. And so we get the definition, cosine square of theta minus sine square of theta. The last one is tangent 2 theta equals to tangent theta plus theta. And if we just plug in those values into the sum formula for tangent, we get the following. Okay, so plug in tangent theta plus tangent theta over 1 minus tangent theta times tangent theta, and we get 2 tangent theta divided by 1 minus tangent square of theta. Okay, so if we do an example, so this is a type of problem that we can expect to see, and we're told that if sine of theta is equals to 5 over 13, and we were also told that theta is in quadrant 2. So what we have to do is draw a little triangle representing the situation. So I think by now we should be very comfortable with doing this type of problem. And so try not to forget the SOHCAHTOA acronym when trying to build the relationships, right? So sine is opposite over hypotenuse. So we're missing this value here. And we would have to do 5 squared plus x squared is equals to 13 squared, so x squared is equals to 169 minus 25. X squared is equals to 144. And if you take the square root of both sides, you're going to get plus or minus the square root of 144, which happens to be plus or minus 12. Now you have to decide, is it going to be a positive number or a negative number? And since x is negative in the left direction, or the second quadrant, then this is going to be negative 12. Okay, so if you don't know how to figure out those values, I hope that little example helps you to figure out missing values on the triangle. So now that we have the triangle fully developed, then now we can do the solutions to these problems, right? So we're looking for sine of 2 theta, and we said that that's going to be 2 times sine of theta times cosine of theta. Well, what is sine? Sine, we were told that it is 5 over 13, and then cosine is going to be negative 12 over 13. So use our calculator, or just multiply things by hand if you don't have a calculator. So if you do that in the calculator, we get negative 120 over 169. And since it doesn't reduce, that's going to be the final solution. Then, if we do the second example, cosine of 2 theta, we're going to use the formula cosine square of theta minus sine square of theta. So, what is cosine? Cosine is negative 12 over 13, and then sine is 5 over 13, and that is being squared. So once you square that, you get 144 over 169 minus 25 over 169. So 144 minus 25 gives us 119 over 169. And since it doesn't reduce, then we're going to leave it as it is. Then the last part, which is tangent to theta, is going to be 2 times tangent of theta over 1 minus tangent square. Okay, so 2 times whatever tangent is. Tangent is opposite over adjacent. So 5 over negative 12 divided by 1 minus 5 over negative 12 squared. Then we simplify this as much as we can, so this becomes 10 over negative 12 in the numerator divided by 1 minus 25 over 144, and we have 10 over negative 12 over, I'm kind of running out of space here, I'll just make a little line there. This is going to be 144 over 144 minus 25 over 144, so that you know what's going on. I'm going to continue here. So 10 over negative 12 is the numerator. And again, 144 minus 25 is 119 over 144. Then we'll do the keep change flip. So we're going to keep the number in the numerator as it is, and then flip the denominator fraction. So we have the following. So once we multiply that, then we get negative 120 over 119. Okay, so that's how we find the three different double angle formulas for any given sine value or cosine. You know, we could be giving any number. What we have to do is create the triangle correctly, figure out the length of each side, and then build everything else. Now there is a interesting part about cosine 2 theta, is that it could have three different definitions. So these three definitions work for cosine 2 theta. So if you, for example, only know sine and you're trying to figure out cosine of 2 theta, well, you can use the bottom definition. You don't have to develop a triangle and figure out what is cosine, what is tangent, what is sine. Like in the previous example, we were given sine of theta. Well, I could easily figure out cosine of 2 theta using the last definition. On the other hand, if I was given cosine by itself, then I don't have to do extra work to figure out what is sine in order to figure out cosine of 2 theta. I could just use the middle definition. Okay, so it's just a matter of preference, whether you want to figure out other values or not. Okay, then we could have problems where we're trying to figure out identities, like this one. So what can we do? We could perhaps work on the left side. So we'll do the solution here, and I'm going to start working with the left hand side with the cosine of 3 theta, and I'm going to rewrite it as a cosine of 2 theta plus theta. Okay, so that right there can allow me to use the sum and difference formula, right? So I'm going to rewrite this as cosine of 2 theta times cosine of theta, minus sine of 2 theta times sine of theta. So notice how I ended up with these two pieces that have a double angle. So I'm going to use the definition and substitute in a different value for those. So that right there, we can rewrite it as 2 times cosine theta minus 1 times cosine of theta minus 2 sine theta times cosine theta times sine of theta. Then we can distribute this in here, and we'll have 2 cosine to the third power of theta minus cosine theta. Then we'll have 2 sine square cosine square, because those two multiplied to give me the sine square of theta. Then, now that I have that part of the 2 cosine to the power 3 theta minus cosine theta, then I can use the power definition that we covered. So 2 cosine cubed of theta minus cosine minus 2 times 1 minus cosine square of theta times cosine of theta. And then if I distribute this, I'm going to have 2 times cosine theta minus cosine cubed of theta. And I guess I can rewrite this as 2 times cosine of theta minus 2 times cosine cubed of theta, and then get rid of that last parentheses. We can then combine like terms, and we will have 4 cosine cubed of theta minus 3 regular cosine of theta. And so this, we have shown that the left hand side is equals to the right hand side of the equal symbol. Okay, so that's how we would do a verification of the identity, right? So it's very intense in terms of like what we're doing. So you have to be really knowledgeable of like the definitions and how to replace, you know, something. For example, you see a cosine 2 theta, then you can say, okay, I can replace it with this definition or the other definition. So you have to be very knowledgeable and creative. The next thing that we have to cover is something called power reducing formulas. And so what it means is that you could have sine square of theta, right? And you want to rewrite it in terms of something that doesn't have powers. It's just maybe a double angle or something like that, like we're showing here. So double angle formulas help us create power reducing formulas. So sine square of theta is equals to 1 minus cosine 2 theta divided by 2. Right, and if you look back at the other definitions, I think cosine of 2 theta was should be 1 minus 2 sine square of theta, right? So if you're trying to solve for this, then all you have to do is take away a 1, then divide by 2, negative 2, and you're left with 1 minus cosine 2 theta divided by positive 2 equals to sine square of theta. Right? So that's what we mean by we use the double angle formulas in order to come up with the power reducing formula, since that's just one example, right? For cosine square of theta, this is the definition: 1 plus cosine 2 theta divided by 2, and tangent square of theta is equals to 1 plus cosine 2 theta divided by 1 minus cosine 2 theta. So in other words, I just showed you how to do one of them, right? How to derive the power reducing formulas in case you ever need them. So the same way that we just did. This one is already done in the previous slide, but this one we didn't do, so we can start by adding the 1 from the other side, and then we're going to divide by 2, and we're left with cosine 2 theta plus 1 over 2 is equals to cosine square of theta, right? So that was the definition that we showed in the previous slide or previous screen, and it's all about just algebraically solving for an expression, right, of your choice. You have to kind of get used to being able to solve for things so they can fit your needs in some way. Okay, so just how there is double angle formulas, there's also half angle formulas. And so what it means is that you have the argument that you're plugging into the function as half of a regular angle. And so one definition is sine of alpha over 2, or the half angle of alpha. And the definition is plus or minus the square root of 1 minus cosine of alpha divided by 2. The other definition is cosine of half angle of alpha is equals to plus or minus the square root of 1 plus cosine of alpha over 2. In the last one, we have tangent of alpha over 2, or half angle of alpha, and it is equal to plus or minus the square root of 1 minus cosine alpha over 1 plus cosine alpha. So this is one definition, one way to show or figure out that solution. But then there's also another definition, which is 1 minus cosine of alpha over sine of alpha. This one doesn't include any radicals. But then there's also another definition for tangent, which is sine of alpha divided by 1 plus cosine of alpha. So tangent in this scenario has 3 different definitions. Okay? So for the first definitions in all 3 of them, there's a plus or minus square root. So that doesn't mean that there are 2 possible values for each solution. It does not mean that. What it tells us is that you have to figure out whether your solution is going to be positive or negative. You have to pick. And you determine that based on what quadrant is the half angle on. Okay? So if you remember the the 4 quadrants where we say all students take calculus or a smart trig class. If your half angle is in the first quadrant and you're evaluating tangent, cosine, or sine, it doesn't matter because all of them are positive here in the first quadrant. If your half angle falls on the second quadrant, then only sine is positive. So if you were doing sine of half angle or something and it lands on the second quadrant, then your answer is going to be positive. If you're doing cosine of that same angle, then it's going to be negative because only sine is positive in that quadrant. Okay? Let's do an example. So we want to find the value of cosine of 112.5 degrees. Okay? So we know that 112.5 degrees is the same thing as 225 degrees divided by 2. So the point is that you don't have decimal versions in the unit circle. At least we don't know those exactly, right? We only know like nice round angles like 30, 45, 60, 90, multiples of 30, and then a couple multiples of 45, but no decimals, right? So here is where we have to start figuring out 112.5, if you multiply times 2, it gives you 225, and that's on the unit circle. So that's how we're going to figure out that in this case, alpha is equals to 225 degrees. So another thing that we can try to talk about is it going to be positive or negative, right? So notice where 112.5 lands on, and 112.5 degrees is on quadrant 2. Okay, so quadrant 2, like I told you a second earlier, only sine is positive there, but since we're trying to figure out cosine, then our solution is going to be negative, right? So we're going to have a negative solution. So let's do the work. Cosine of 112.5 degrees is the same thing as cosine of 225 divided by 2. Then if we use the definition, it's going to be negative square root of 1 plus cosine of 225 divided by 2. Then negative square root of 1 plus, what is cosine of 225? So it is negative square root of 2 over 2, and all of that is divided by 2. And so, not to get confused, it's all under the radical. So at this point, we're just trying to simplify whatever is under the radical. So I'm going to write that 1 as a 2 over 2 so that I can subtract it from the square root of 2 over 2 fraction, right? So at this point, we're just trying our best to simplify things. So 2 minus the square root of 2 divided by 2, and all of that is divided by 2. So we're going to do keep, change, flip, and we have 2 minus the square root of 2 over 2 times, since this guy up here was a 2 over 1, this becomes 1 over 2, right? And that is all under the radical. And we have 2 minus the square root of 2 over 4, right? Because the 2 times the 2 in the denominators. Then, we're almost done. We have 2 minus the square root of 2 over the square root of 4, which is 2, right? So, and we're done. Okay, we've shown how to figure out, or how to figure out the half angle of something. So the first details are kind of simple, right? You figure out where it's going to land and what are you going to plug in. But definitely the hardest part is getting the exact solution at the very end, right? If it gets too confusing, then you make mistakes and you won't be able to get the right answer. Okay? But for the most part, that is all of the different formulas for section 5.3, right? So that was the double angle, power reducing, and half angle formulas for section 5.3.